Hello everyone. I am pleased to welcome you to the course dedicated to working with the Topoplan module. The Topoplan module is an engineering solution that expands the capabilities of the nanoCAD platform in creating a digital terrain model and preparing drawings for the release of topographic plans. The module makes the work of the survey engineer more comfortable and efficient. All the functionality for working with the module is gathered in the Topoplan ribbon tab, which becomes available upon purchase of the corresponding module. In this lesson, we will pre-configure the program for comfortable work, import our first model, and build a tin surface. To work with geodetic survey data, you need to use a drawing template with units set to meters. To set the metric template as the default, open the Options dialog using the Options command. Next, go to the Template Usage menu item, where you need to change the default template in the For New Document sub-item. Replace the default template file default.dwt with nanoCAD earthwork metric.dwt. You can find this template in the Templates folder. Alternatively, you can click the nanoCAD button and go to Options, where you can change the template file in the same section. Let's create a new document and see that the new template has been applied. Before starting to work with the Topoplan module, you need to set the desired topo scale. To do this, go to the Topoplan tab, where in the Settings group, use the Toposcale command to select one of the default options or create your own. The functionality of the Topoplan module is essentially a universal tool that allows you to use point clouds, coordinate geometry point data from a text file, and height matrix formats as input data. We will sequentially consider the options for using different types of source data to create a surface. In this lesson, we will only look at the most common types of source data. First, we will consider an example based on working with a point cloud. Load the data by going to the Point Clouds tab, where in the group of the same name, select Import. Select the point cloud and Import Settings window will open. On the left, we can see various data about this cloud. A little below, you can check the drawing units and set the point cloud thinning factor. This option allows you to reduce the number of imported points several times, in accordance with the specified number. If necessary, we can convert the EPSG when importing the point cloud. In the Upload field, we can specify which metadata to upload and which not to, as well as specify the necessary codes. In the Import Settings field, specify the units in which our drawing will be displayed in the program. In this case, I will leave millimeters. Leave the other settings as default and click OK. As a result, we transferred our point cloud to the program. Now let's consider using a text file as the source information for creating a surface. To do this, go to the Topoplan tab, and in the Import or Export group, activate the Import GeoPoints command. The Import Settings window will appear. Let's open the required file using the Open File button. Specify what separates the information in the text file and from which line we will import the information. In our case, the separator is a tabulation. Next, distribute the information fields by specifying the correspondence of the data for X, Y, Z. The GeoPoints data in the file comes without accompanying information, so we will take the data from the first line. We also have the option to specify the name, elevation, code, and create a polyline when importing data. In the additional options, you can set the drawing units when importing data. Complete the import operation by clicking the OK button. By default, the program places the uploaded points on the 0 layer. To correctly save the information, create another layer GeoPoints in the Layer Properties and move the created objects from the 0 layer to it. Save the drawing to fix the import result. Let's create a tin surface based on this imported surface. To do this, go to the Topoplan tab and use the Create Tin by Points command. The command will ask you to select the points that will be used to create the surface. Select the points using a selection box and confirm the action by pressing the Enter key. When creating the surface, set the parameters for the creation result to Subdivision Mesh. In the Filtrate Source Points field, select No, as data filtration is not required since the data volume is not excessive. In the Build Boundary from Convex Hole field, select Yes, which will open additional fields. This will allow us to set the maximum edge parameter, which will enable us to get the external boundary and trim the edges that extend far beyond the surface while creating the surface. To do this, set the Only External Boundary field to Yes. There is an option to set the maximum edge, but first, it is important to specify the units in the Maximum Edge Units field. Set the Maximum Edge Units field to Length Unit and the value in the Maximum Edge field to 65. The Minimum Triangle Angle field specifies the minimum angle in a triangle below which it will not be filtered. A value of 0 disables angle value filtering. In the Minimum Triangles field, specify the number of triangles to be removed. When constructing a contour from several triangles, many small islands are created. Islands with fewer triangles than specified in the parameter will be removed. Let's set the values in the Minimum Triangle Angle and Minimum Triangles fields to 0. Set the Break for Optimization field to No and the Create Layer field to Yes. I recommend leaving the other parameters unchanged. For more detailed help, refer to Help by pressing the F1 key. Confirm the parameter changes by selecting Yes. And as we can see, a mesh object was created on a separate layer called Tin Surface. We can convert this object to another type at any time using the commands Convert to 3D Faces, Convert to Mesh, and Convert to Polyface Mesh. For example, let's use the Convert to 3D Faces command. And as we can see, our separate mesh object has become a collection of 3D face objects. Undo the changes using the Ctrl-Z key combination. Some commands require additional parameter settings, so I strongly recommend referring to the help by pressing the F1 key and carefully studying these parameters. Similarly, we can convert a point cloud into a tin surface. Let's go back to the first file. An important step before creating a tin from a point cloud is to explode the cloud and represent it as an array of individual points. To do this, use the Explode the Cloud into Points command. After activating the command, parameters will appear on the left that need to be configured. In the Result Type field, set the parameter to points. Let's delete our original object, so in the Delete Source field, select Yes. And in the Use Class field, you can specify the ground class. Confirm the changes, and the Point Cloud Explosion Settings window will open. In this window, you can configure the parameters for exploding the point cloud. Specify which layer these cloud points will be moved to, set the color, and specify similar parameters for metadata. These parameters will later be displayed in the drawing. Let's leave the name, elevation, and code fields disabled. Click OK. Now let's create a tin surface based on these points without changing the settings. We see that a surface has been created. Let's change the display style to realistic and turn off the ground layer. For clarity, use the Mesh Coloring by Height command. Confirm the changes without changing the parameters, and we see that our terrain is colored according to height. This concludes our lesson on importing and creating a tin surface. In the next lessons, we will look at working with surfaces, as well as drawing contours. Thank you for your attention. See you in the next lessons.